Hi everyone, so we're picking up where the recording left off. I realized I hit stop recording before I'd finished my sentence. All I was effectively saying was that chapter 9.4 is particularly math heavy, so that's why it took a little longer than I expected, and why I gave it its own distinct part of the study checks. And mind you too, these aren't the required parts of the videos. These are here to help you hone your problem solving skills so that you can do well on the homework and then ultimately do well on the exams, right? So again, if you find out you don't need this type of instruction, then you are not obligated to watch. And if you find places that are good for you and others that aren't, pick and choose. This is a little bit more free form for you guys. But I'm going to keep chugging through those remainder of the study checks for chapter 9. So everything that we dealt with in chapter 9.4 was just about making solutions, and then how much stuff or how many moles or how many grams are dissolved in a given amount of solution, right? And we talked about different types of percent composition, mass, volume, and then molarity. And now what we're going to dig into is what happens when we need to dilute those solutions. So very common in medicine and very common in all sorts of hard sciences like biology and chemistry, solutions are usually made in a higher concentration than they are needed, so that a small amount of a high concentration can be taken, making a small dilution to get to the concentration you want. So it's a very common technique to make high concentration solutions and then dilute them. So here, this is probably going to be another math heavy section, but I don't believe there's as much not as much processing involved, and they're a little bit quicker problems. And I'll try to be a little bit more succinct as well. So it's saying what volume, that's what I'm trying to solve for, of an initial amount, a 2% mass per volume solution of hydrochloric acid, right, can be prepared by diluting. So this is going to be my new volume. So, 25 mils of that solution. Diluting 0.25 mils of a 14% solution. So again, sometimes the way things are wording, it can be confusing. So what I like to do is, again, organize my givens and finds, right? So it's talking about an initial solution. I'm just going to name this one M1. It's in mass percent, but doesn't matter. We can use M1 and why? Because the equation that's been the focus of this chapter, or this section of the chapter, focuses particularly on this equation that is used only for dilutions, right? We don't use it for making solutions, only once the solutions have been made, right? So we have an initial concentration, which I'll say call M1. You can call it C1, doesn't matter. And it's 2% mass per volume, specifically of hydrochloric acid. So what volume of this can be prepared by diluting? So actually, if I was going to phrase this maybe a little bit differently, maybe I'll call that M2, right? So this is more, using subscripts is for you to start organizing the data that makes sense to you. So I jumped the gun a little bit. I realized that's the solution I'm trying to make, 2%, so I'll call it M2, because that's what I'm trying to get to. Because the stuff on the left-hand side is always what you start with, and anything on the right-hand side is where you're going, right? And so I'm going to this concentration of 2%. So it's saying my initial concentration, I can use C1 or M1 again, started at 14% mass per volume. And good, we're still in the same compound of HCl, except that initial amount I started with was 25 milliliters. So it's asking us to find, effectively, V2, because that's going to be the volume of this 2% solution. It's just going to happen to be in units of mils. How do I know that? Well, one thing I don't think we touched on in the last video, the reason why we can switch between molarity or mass per volume, whatever I want, as long as the units for what your concentration are consistent, so in this case, mass per volume, if I keep things consistent, the math works out no matter what. If I use what we're using in this equation, which is percent mass per volume in milliliters, could also be molarity in liters, It could also be molarity in microliters. As long as we keep our units consistent, we'll have no problem with using these equations. So let me get rid of all that. A lot of talking again. Sorry for little payoff. But I want to make sure, part of these, a lot of people can just follow an answer key. I want to make sure that what I'm providing you in a video is something that augments an answer key or is better than an answer key, because I can explain the little details. So if the equation we'll be using, and we switch back to blue, I liked using that to help me visually to separate work from what's given and found. So I'm going to switch that to blue. So the equation we'll be using, again, I don't care how you call it, M1V2 equals M2V2, or C1V1 equals whatever, C2V2, as long as the essence of the equation is correct. Oops, sorry, I was dusting something off my screen. So I take a look. What am I asked to solve for? V2. So let's isolate V2. If I divide both sides by M2, I end up with M1V1 over M2. And so now I can plug in the information that I know. So I'm going to have to erase a little bit. And again, not very good with my space management. But if I rewrite that again, M1V1 over M2, because I'm solving for V2. Plug in what I know. My M1 was 14%. My V1 is 25 mils. My M2, I want to get to a final usable concentration of 2%. You'll see, again, this is what I was trying to get at with the units. Percent cancel out, and I'm left with units of milliliters, which is a unit for volume, so I'm in good shape. We do all that math out. 14 times 25 divided by 2. V2 is 175 milliliters. What is that telling me? Well, that's saying if I took all of this solution here, the 25 mils of 14%, and then diluted all of it to 2%, well, that final volume would be 175 mils. And that makes sense. As my volume increases, so I'm going from 25 to 175, you'd expect the concentration to decrease. It's the same amount of stuff, just in a bigger volume. All right. So let's tackle this problem. So it's asking me again, what is the percent mass per volume of a solution prepared by diluting a 10 ml solution at a concentration of 9% NaOH, and I'm diluting it to a final volume of 60 mils. So again, givens and finds. The hardest part again is going to be deciding what is M1, what is V1, what is M2, what is V2. So one little hint that can help things out too, we can immediately see that's a concentration, so I know what I'm solving for is definitely going to be an M. Is it M1 or M2? Got to figure that one out. Usually because I'm saying of a solution prepared, that means what I'm solving for is going to be what's going to be the final solution. So what happens after I do the diluting? So I'm getting a hint that it's telling me M2. It's saying it's diluting from this solution. So this is probably my M1 and my V1. And I'm going to a volume. So that's probably going to be V2, because this is where I start, and I'm always going towards where I end. So let's take this information then, and then dump it into our givens and finds. So we know we have a starting volume of 10 milliliters. That's starting concentration. Oh, let's see. We'll leave it this way, keep consistent. That starting concentration happens to be in mass per volume. I'm not too worried about that, right? We said, and like we've said a bunch of times now, those two equations are 100% interchangeable. My initial concentration was 0.9% mass per volume, sodium hydroxide. and I'm diluting to a final volume of 60 mils. So I'm asking, what is going to be the concentration of that solution in units of percent mass per volume when V1 and M1, this solution here, has been diluted to this final volume V2. So we have our M1 V1 equals M2 V2. I'm solving for M2 now, so divide both sides by V2. So I can solve directly for M2. M1 was 9%, V1 was 10 mils, V2 was 60 mils. What will M2 be? I can definitely know the units right off the bat. Mils and mils cancel. My units will be in percent mass per volume, which is exactly what I want. So let's find a number that goes with this. 9 times 10 divided by 60. So let me just make sure I was clear with what I was writing. That's a 10, right? You almost confused myself. M2 in this case, I get 1.50. So your calculator probably gives you 1.5. Realize we got to go to 3 sig fig. 1.50, and that's going to be in percent mass volume. Again, you could have done the same equations with the C1 V1 equals C2 V2. It all depends what you're more comfortable with. Now it's asking, what is the molarity of a solution prepared by diluting 0.18 liters of this concentration of nitric acid to 0.54. So hopefully you guys are getting a little bit more proficient and comfortable with this. So we're specifically asked for the molarity of the solution. So it's going to obviously be after I do something to it, so that'd be my M2. This is describing the solution I'm starting with, so there's my V1 and my M1, and that's the volume I'll be ending with, so there's my V2. So let's organize what I have. V1 equals 0.180 liters, M1 is 0.600 molar nitric acid, and my final volume is going to be roughly almost a half a liter. And I'm asked to find directly for M2 in units specifically of molarity. So let's start plugging away. M1 V1 equals M2 V2. I'm solving for M2, just like in the last problem. Divide both sides by V2, so we can isolate M2. Plug our numbers in, 0.600 molar, times V1, which is 0.180 liters, divided by my V2, which is 0.540 liters. I'm solving for M2. Check my units. Liters and liters leaves me with the units of molarity, which is what I'm going for. Oops, let's switch back to the right color. So then I do 0.6 times 0.18 divided by 0.54. M2 is equal to 0.2, and that's what you'll get on your calculator. But again, we got 3 sig fig. So make sure you include your 3. You have a total of 3 sig fig. Remember that first 0 is a placeholder, because I could write that in scientific notation. I don't know why there's a lasso tool. I'm going to get rid of that. Here we go. Units of molarity, right? If I wanted to write that in scientific notation, I could write it like this. So it would be -1. Wow. Molarity, my bad. Here we go. So there's our final answer for that equation, for that problem. So I'm going to keep chugging along with section 9.6 because I believe there's only one practice problem in this one that I'm giving you guys. So the majority of this will be 9.5. So it says a mixture that has a solute let's pull that up. So it says a mixture has solute particles that do not settle but are too large to pass through a semi-permeable membrane. And now they're asking us, is this a solution, a colloid, or a suspension? So let's break down what we're talking about. It's saying that they do not settle. And so if I have my choice of solution, colloid, or suspension, I can immediately see that that's going to rule out suspension because it did not settle, and suspensions do settle. So now I have to ask the question, is it a colloid or is it a solution? So it's too big to pass through semi-permeable membrane. So I'll say SPM. So again, we have a choice of a solute, so it has to be a solution, or it could be a colloid. And solutions, we said, are going to be the particles are very small and they can easily pass through semi-permeable membranes, while colloids cannot. They're medium sized, so they're a little bit too big to pass through. That means we are looking at a solution. Oh, wait, did I screw something up? Colloid? Oh, sorry, my logic was backwards. Sorry, we were searching and saying it didn't pass through. It was too big, so it has to be a colloid. Sorry. I was like, wait a second. I thought I knew what I was talking about, and apparently I still do. So that's always a good thing. All right, so that's going to end our study checks for Chapter 6. Again, we said this is kind of trying things out, what's going to work best. I know what I did before was record videos when I was at Emmanuel, but now the campus is open per se, but more than likely I'm not going to be traveling in to record videos there. So we're going to have to work out a solution where I can do this from home like this. All right, so I hope everyone's staying safe. Hope everyone's keeping up with the material, and I will see you all tomorrow morning. I will send out, so that's going to be Monday, the 23rd, if you're watching this on Sunday or some other time. But yeah, I'm talking specifically about Monday the 23rd. Like always, I'm going to send out a link to the Zoom so we can have our online meeting. And so what that's going to be is mostly focused on basically these study checks. It's going to be a lot of hopefully group work, not group work, but work with me to work through problems, but specifically geared towards questions from specific students. So please think of things in advance, so it's not just going to be us sitting there like, what do we do? I just want to make sure we have problems to do so we can use our time effectively. All right, so stay safe, and I will see you all later. Could also see you all later if I could actually shut down some of these programs. Almost. Come on.